All right, everybody, I think we're going to get started here. This is being recorded, so, I know we're going to go through a lot of information that may or may not be new to some of you. So we'll be able to play it back later, but I'm excited to introduce Michael Gold. Michael has been in this Bitcoin NFT blockchain space for many years, but not just that, he's also an expert in the metaverse, or what used to be called VR, AR, XR industry side of things. He's a professor at one of the top New York art schools in terms of digital art. He's also the founder and CEO of Shaderverse, which is a plugin for Blender, which is an app you're going to learn about today if you don't already know, that allows you to create NFTs directly from the software. And today we're going to learn about generative art. Maybe some of you have conception about what generative art is, but really in the purest sense, really what goes on from a creative coding standpoint, maybe what you've seen from art blocks and how that's being applied to this new phenomenon called Ordinals on the Bitcoin blockchain. But I'll let Michael take it away. Thank you so much for joining us, Michael, and look forward to learning.
Awesome. So I've got a demo project that I'm just getting set up, and I'm going to share with everybody after the course. And I think this is going to be a really great learning tool for everyone. So with that, let me kind of share my screen and show you all what we're going to be diving into today. So I'll just figure out how to do that here on the Zoom. And the host disabled screen sharing. So Scott, can you enable that? Let me try it again.
Should be good now.
Okay, awesome. I will just grab my Blender project. Cool. So you should be able to see my screen inside Blender now, and I have a little procedurally generated vase right here. And I'll show you what we're going to be learning about today. So this is a 3D vase, and you can see that the sides of it kind of have this Bezier curve type shape, which we'll be learning about. And the inside of it is a hollowed out cylinder. And what's cool about this is that this is generated basically just off of a seed value. And for each seed value, we get a different size and shape vase. So different heights, you can notice, different shape of the Bezier curve, and different color. And this is all being generated from a seed number. So we're going to learn a little bit about that. In fact, in this demonstration file, which I have a few different, or 16 different primitive procedural node shapes, which I'll have a full YouTube tutorial for, like how each of these shapes work and kind of what you can use these for procedural modeling. But for today, we're just going to be looking at this type of spline curve and how it can be used to make procedural shapes. So that's what we're going to be diving into today. And the really cool thing about this and this type of art is that you can have one generator file that's very small that you can store on the Bitcoin blockchain through Ordinals, and then that can be used to generate thousands of pieces of unique art. And that can all be regenerated in very high definition. If you notice, as I zoom in on this shape here, and if I add in one more node to shade it smooth, you'll really see that it's all regenerated from each view and at the highest definition that I'm zooming in on. So that means that as displays progress, well past 4K to 8K to 16K to 256K resolution, the art that you make with procedurally generated tools such as Blender, such as the Shaderverse add-on, will be future proof in terms of the resolution that you'll be able to make it in, and stored if you store it on Ordinals, store it on the Bitcoin blockchain for as long as Bitcoin exists. So I think this is a really cool way to store art and for artists to distribute art. And we're going to be diving into that today. Now, the way that we make this art inside of Blender is using what's called Blender geometry nodes. And in this node right here, this is a very simple node for a procedural spline. And any of you who have worked in 2D or 3D art before have come across these types of Bezier curves. And if you notice, this is a Bezier segment, and this is a group output. These nodes inside of geometry nodes are like little visual programs where you can control the parameters in on this left side here, and then get geometry output here. So for example, this node right here is making a 3D shape. If we notice, if we look at it, if we look at that curve, it's kind of going out along this axis. Look at it in this view. So it's going out along this axis. It's going over along this axis. So that's the x-axis. And then this is the y-axis. And you can notice my little widget here that shows you how things are moving. And then is it doing anything up along z? Let's take a look. No, it's really kind of flat along z. And if we look at the inputs here for this, we can see how these numbers are influencing the way that this curve works. So essentially, the start is at the 0, 0, 0 position, which is right here. And then the end is at the 1, 0, 0 position, which is right here. And then we have some handles that control this curve. So let's look at how the handles work. There's an X handle, which is at the 0.300 position. And watch what happens if I increase the start of that X handle to like 0.5. Take a look at this. It shifts how the curve starts off over there. And if I shift where the X of the end handle is, right now it's at negative 0.5. If I shift that to like a positive 0.5, you can see how that moves. And let's drag the end out a little bit so we have more room to work with here. Whoops, I just want to drag that out to maybe 5 here. Now, if I set the X down here, you can see how I'm shifting this curve. So what this is giving us is it's giving us the ability to work with any of these spline curves procedurally. And it lets us manipulate curve along all of the axes, the 3 axes, X, Y, and Z that we want. So I can move my handles up along Z. And now all of a sudden, you see, I've got a 3-dimensional curve that's shifting a little bit along the Z-axis as well. So this is a very powerful tool. And what's cool about it is that we really only have these 4 inputs here, XYZ, 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 these 4 sockets that let us control everything about this curve, and then it's just interpreted. Now, what's really cool about working with geometry nodes in Blender is that we don't have to set these positions manually. We can use random numbers to control the curves. And before I talk about random numbers, I just want to show you there's one input here that we haven't controlled yet, which is the resolution. And what that resolution means is just how many segments of this curve are we going to have? Right now we have 16. If we increase that, notice that the curve is getting smoother. So if we decrease it, we use less points. It gets more jagged. If we increase it, the curve gets smoother. So here we have 32 segments of the curve. If I use a random number here for my starting handle, we can shape it along the range of that random number. So let's pick a good handle to use a random number for. I think this endpoint would be good to have a random number. And this is basically, if we go back to our vase example, this is how we're shaping the curve of the vase. Every time we generate a new one, we're just using a random number generator that controls the shape of that curve. So let's go back here and see if we can get a random number generator to control the shape of this curve. And the way that we do that inside of geometry nodes is we just press, and I'm going to enable my screencast keys here so you can see what keys I'm pressing. So now let me just make this a bit bigger. Okay, now you'll see my keys in this area here. And if I press Shift A and click on search and type in random and click random value, now I'll be able to get a random value. And I just want to generate one. So I'm gonna pick an integer and an integer and just call this number 0 and plug that into the ID. And what that'll do is this will give me one random number that's unique for each seed. So if I have the seed of 0, it'll always be the same random number. And I'm going to plug that in to the end of my X so that my curve will be able to be a different length. And this is all done visually using these nodes with no code. So we're able to program this with no code. And if we notice here, I just have one value, but I really want that. I want this X and Y to stay the same, and I only want to change the Z. So what I need for that is a combine XYZ node. And what that node does, if we look at it, is it takes in 3 values and it outputs one vector. And these colors line up the same. The purplish color is a vector. So what I can do is just copy these values in here for X and Y so that those will always be the same. It's working. 6.1, and now my Z value is going to be 8.6. We'll keep that at 8.6. And I'll show you that if I plug this in here, the curve didn't change at all. I'm just using these values for X, Y, Z. And now I can plug in my random value for Z. So let's say I want that size to be between 5 and 8. And I plug this in for Z. And now I have, oh, I actually wanted that to be random for X. So I'm going to plug that in to this one. I wanted the end value random for X. So let me use these numbers, 10, 0, and 0.2. I didn't want to change the handle. I actually wanted to change the distance here for X. So right now it's 10.5. So I'm going to do a range between 5 and 10 and hook that up to the X value and hook that up to the N value there. And now when I vary my seed, I'll have the distance increase or decrease from 5 to 10 along this X-axis. So that is a way that we can use the random number generators from Blender to make different shapes along the X-axis. So what that's doing here is allowing us to control the shape of this curve. Now, I can make another random value generator and use that to control a different aspect of this curve. And the way that we do that is we can just select these two nodes, press Shift D to duplicate them, and now we've got another random value that's being combined into an XYZ vector. So let's say I want to change the end handle this time. And the default values where I started from, what I like, are 1.2, 6.1, and 8.6. So I'll just type those numbers in there. And you see the process here. The process is really coming up with a shape that you like with parameters that you like, and then figuring out as an artist what ranges of those numbers I want to randomize and use random values for. What are the ranges that look good to me as an artist? So I can look at this and say, okay, this is going up along the Z-axis, this curve right here. It's going up to 8.6. Now I might want to tune that and mess with the height from about this level, which I look on my chart. This is like about 3. And then I want this to go up to about 9.2. I think that's a good range. So I set my range here, 3 to 9.2. And I hook that value into the Z. And why did the curve go down? Oh, it's because I didn't set 0 as the ID. So I got a red line here because it's trying to come up with numbers for every point along the line. So if you only want one number, you have to hook the 0 into the ID, because this is only going to do it for the first number in the range, which is 0. So now I can vary the height of the curve, and I can vary the length of the curve according to the seed. Now, if I want to be able to control the seed for each of these with just one integer, all I have to do is add another integer here. So I'm just doing add an integer, and this number can be our seed. And then I just feed that into that seed and feed that into this seed. And now we're using the very same ID for each of these random numbers and the very same seed for each of these numbers. And the cool thing about this, the really cool thing about this, is that we will get the exact same output. Every time the seed is 1, it's going to be this shape curve. Every time the seed is 2, it's going to be this shape curve. Every time the seed is 3, the curve will look exactly like this. Watch, I'm gonna go back to 1. We'll get that small curve. Oops, type in +1. We'll get that small curve. If I go to 3, we're gonna get that bigger curve. Now, this is really important when you wanna, if you wanna make a collection of 10,000 of something, you're going to want the exact same value for each token ID to be made from these seeds. And this is how all of the art in collections on art blocks like Fidenza and all of that were made, except the programs for them were done in JavaScript, not using simple nodes like this in geometry nodes. And if you go on YouTube and look at geometry nodes, there are thousands of great tutorials that have been written over the past year. But using spline curves is a great way to get procedurally generated art inside of Blender. So I don't know, Scott, should we give people a challenge or like to do something like this themselves, or should I just keep teaching for the whole hour?
I think it's best to teach because I think a lot of people are absorbing this and they're going to rewatch. And then maybe
Sure.
at the end, we can go through challenges and questions.
Awesome. So let's see, what do I want to show next? We can turn these curves into 3D meshes very easily with geometry nodes. Let me change this to because we're not actually working on a vase right here. This is our procedural spline. Okay, so if right now this is just a curve in Blender, but the cool thing about Blender is that we can make 3D meshes, and there is a node to turn something into a mesh. So to do that, all we want to do is search for the curve to mesh node and put that in here. And that lets us pick a profile curve. So we have the length of this curve right here, but the profile of it is basically just like 1 point wide. But if I add a circle in here, a curved circle, what that'll do is turn this into a tube, because along every point interpolated through this curve, it's going to place a circle kind of going along that y-axis. So take a look at this. We'll set the radius of this to maybe 0.1 meter, and we'll plug this into the profile. And now we've got this nice tube going along. And if you notice, the ends of the tube are open. If I click this, it'll fill the caps of the tube. I just checked off that box. And we've got hang on, froze a little bit. We've got this cool tube. And now, maybe make the radius a little bit bigger to 0.5. Just zoom in so everybody can see. Now we've got this cool tube, and it still works with our seeds. And I can actually make that X length a little bit bigger, so we can stretch it out more. Now the max is going to be 30. And if you notice, it still kind of has that same shape for the seed. In fact, 3 should still be that big one, and 1 should be that smaller one. So the seeds still produce similar results, even though we tweaked and tuned our parameters. Let me just adjust this, move that out of our way a little bit. And we can see how that curve reacts based on the random seed. Okay, so the next thing we might want to do is add some color to this curve. So what we can do for that is we can pick a hue for this based on a random number. So I have a shader set up that looks for a random number and applies that to a hue, which I'll show you in a moment. But first, let's set the material to use that shader. So I can set the material to use this vase color, which I made already. And that vase color is not going to change yet. It's just red. And if you notice, it's a different color than this one. And the reason for that is that it's looking for a hue number. Right now, this red color is just the color when the hue is 0. So let me show you how this shader works. And if you've watched my other tutorials on Blender, you'll know the basics of shaders. But basically, this shader right here is accepting in a color, and it's looking for an attribute called vase hue, which is just a number. This is plugged in here. So now when the number is 0, everything's red. If I crank this up, you see the range of numbers that it goes through as I increase the hue from 0 to 1. So all we need to do here is come up with a random number from 0 to 1 and store that as an attribute called vase hue, and then we'll be able to color our tube here. So we're getting really close to shaping a vase and coloring a vase the same way we're coloring our little tube here, just with a few nodes. So let's go back to geometry nodes and we'll look at this and we'll think about how we want to color this thing. So we know how to make random values from 0 to 1, or from any number to any number. So we have like our range here from 5 to 30, or range here from 3 to 9.2. Let's make a random number from 0 to 1 that uses our seed. And the way that we do that is we just duplicate our random value by Shift-D, and we use the seed, the integer ID of 0, and the same seed that we're using already. And we change it from 0 to 1. So the start's going to be 0, the end's going to be 1, because that's what our hue needs. And then we are going to do a store named attribute node. And we're actually going to drop this in here right after our curve to mesh, because we want this to be saved on the geometry. And then we plug in the value from that we generated, our random value here. And we call this vase hue. And if we notice, our seed here is changing the color of our tube based on the random ID. And then we can, if we disconnect the random ID, let's just move this out of the way a little bit. If we disconnect the random ID, we can actually control this here from 0 to 1. It gives us unique values. So if we connect it, it's being determined from the seed. And the one thing left to control it from this generator, from the Shaderverse generator here, is actually to parameterize the seed value. So what we can do is we can hook up that seed value to allow the generator to control it. Right now, it's only being controlled from within the node. But if we just add a group input node, we can hook the seed values up to the input of the node just by dragging that up off of there. and dragging that in here. And dragging that off of there and dragging that in here. And now we will get the same seed values as are being generated right here for the node, for the vase. So that both the tube and the vase are using the same seed values. That's giving us the same hue from 0 to 1. And the colors are matching from 0 to 1. So again, our node tree right here, only about 10 or so nodes, and we've been able to make a pretty interesting shape that is procedurally generative every time, just based off of the seed value that we get a unique shape here. And every single time we use the same seed number, we get the same exact shape. So this, in a nutshell, is how you can control generative art just based off of one value. Let's go into this vase. I'm sure, just to recap really quick, we were able to assign, we're not using this integer anymore that we made for our seed, so it's not hooked up to anything, so we can just delete that. And the seed here is the same as the seed that's being generated by the Shaderverse add-on. So now we've got the same seed used for our spline, which we filled in with a profile curve as a curved circle, and our procedurally generated vase here. Now, this vase is a bigger group of nodes, but when we look at it like all together, it's like, oh my God, this is a lot. This is a lot. But if we break this down and we look at it, if we break this down and we look at it, it's really not that much. What we're doing is we have a little random number generator that's being used for the height of the node. We're doing a combine XYZ for that height. And then we have a few more groups of nodes that can be used for the start handle position and the end handle position. We see they're not hooked up yet, but I'm going to hook those up. And then we have a group of nodes that are used for the hue. And then we're setting the material to vase color, just like we did before. So what's happening here that we haven't looked at yet, which we'll get to, is the actual procedural generation of our vase. And I can do select this and press Control J to join this in a frame, and then just rename this in the label here to procedural vase, and we have a little title for it. So that's how you kind of make the frames. And then what's nice is you can organize these and move them. So let's dive into how the vase is being generated. And we'll zoom in on that. Okay, so the first thing here, if you notice, we have a Bezier segment. Then what we're doing is we're using that Bezier segment as the profile for our curve, just like we used a circle for the profile for a curve in our tube, and we are transforming it with a 90-degree rotation. So basically we have our Bezier curve, and then to get that curve to apply to this circle and stretch it out along the Z the z-axis here, where we have to rotate it by 90 degrees. If we just have it at 0 degrees there, it doesn't really do much for our curve. So we need to rotate it by 90 degrees. So I just use this transform node, which lets us do all of the standard transformations that we might do in Blender. Translate something, which is moving it along the x-axis, y-axis, or z-axis, rotating it along those axi, or scaling it along those axes. And the default scale is, of course, 1, and you can go up or down with those transformations. So this we've all seen before. Then what's happening here is we're using this value right here for the radius of the curve. And this value here could be one of our we could randomize this value because it gives us different results, because this is determining the circle that starts the top, both the top and the bottom of the vase. But we'll just leave that as 1 for now. We also have a value that we're using for the depth of the vase, like how high is it? And that is here, and it's coming from this value here, which is a random number generator from 3 to 6. And we can, of course, adjust the ranges there and make it a little bit bigger if we want. So what's happening over here? In this area here, we're making a cylinder. And why do we make a cylinder inside the vase? Well, the reason why, let me just mute this node and you can see what's happening without it. Without the cylinder, we notice that we have our outside spline area for the maze, but open on both the top and the bottom. So we make this cylinder, and what happens is let me see if I can show you with the cylinder how that looks. There we go. I just Alt-Shift clicked on it, and what that did is it hooked this node up directly to the output over here and ignored all the other nodes. So we have this cylinder that we make, and we translate it up by 50%. Because if we didn't do that, if I just had the cylinder made without the translation, it basically starts it and puts it at 0, 0, 0. So it's half from the top and half from the bottom. And we actually want it to be the same exact size as our vase and the same position as our vase. So it's the same height as our vase. And now it's in the same position as our vase because we moved it up we multiplied 50%, 0.5 of that same value, the height of our vase. So we're just moving it up along the z-axis by 50%. And not only were we moving it up by 50%, but we're making a copy of it, and we're scaling that copy by 80% along the x and the y-axis to essentially take a chunk out of the vase by that amount. So we basically do what's called a mesh Boolean difference, where we're subtracting a smaller version of that cylinder from the cylinder itself. And what that does is it carves out a section inside of that. So if we never did that mesh Boolean difference, the vase would be solid all the way through because we just inserted a solid cylinder into it. But here, now, I'm taking the difference of a smaller cylinder that's the same height, the height is 1, but the x and y are 80%. And watch what happens if I change that to 90%. the rim gets a little bit bigger. If I change it to 70%, the rim gets a little smaller. So this is another value that you can randomize because I find a range that I like. So it's all about finding the range of things that you like that gives you good results in your eye as an artist, and then parameterizing those as random values. So with that, we come up with our vase hue again the same way we did it before, and we set the material, and that's how we make our vase. It's just using a spline, and it's using some very simple math where we're taking, like 80% of the radius for a cylinder. We're making a cylinder to carve out the insides of it, and we've using random values to set the heights, and we can even use these random values for the handle position. So if I wire this up to the start handle position, let me show you how creative we can get with this. So I'm wiring that up to the start handle position. Now we've got a little bit of a different shape. I'm wiring this up to the end handle position. Now we got another shape. Now look at this. Now, as I generate my vases, I'm getting way more variety in height and shape than I was before, because the handle position is also varying. And I can change the radius too, if I want, just by making another random number generator. So where was the radius? It was this value right here. So I can make another random number generator just by duplicating this, and call this width, and change my radius from 1 to 2 maybe, and just plug that in to the same values here. And now I'm not using this value anymore, but I'm using this. Oops, sorry, my computer's slowing down a little bit. And now you see, when we generate it, let's see, is our width changing? Let's make it a little bit more dramatic. Let's go from 1 to, go from half, 0.5 to 3. Give it a bigger range so we can really see the variety here. Now we see the width of the top is way different based on our generations. The width of the bottom always matches the width of the top, which is kind of by design here. But we get a nice different variety of pots that we make, all procedurally. And every time we have the same seed, we get the same exact pot. So that's really the end of the lesson. I will post these tutorial files on that GitHub instance. And if you want we'll be emailing the attendees the full YouTube tutorial that shows you how to use all of these different nodes here in your procedural designs, and giving you more information about how you can use this open source toolkit to make generative art NFTs that you share on shaderverse.com. So really excited to see what type of art you make with this. There are loads of tutorials on YouTube for geometry nodes. There's nothing that we showed in here that's different from using standard geometry nodes. So virtually anything you can procedurally model in geometry nodes, you can use that'll be compatible with what you can do on Shaderverse. So this is kind of the quick 1-hour intro to getting started with it. Scott, let me figure out how to unmute you, and stop the screen share. Hang on. And I'll get Scott to unmute. Thank you so much to Scott, Scarlett, Jorge, and the Bit Basel team for putting this together. Really appreciate you, and really looking forward to getting to see what art the artists make here with these tools.
No, thank you so much, Michael, for pushing through it. We have a lot of questions from a lot of people. We shared your first 20 minutes to Blender tutorial with everyone in the crowd and everybody in the chats. And I think we have a lot of creators that want to add 3D modeling to their artistic tool set. So no, thank you so much. We look forward to doing more workshops with you, 101s, 201s, and how to turn these into NFTs. You know, definitely want to keep going with this. If there's any, slight questions, I wanted to, ask, because I know you had a special project, just maybe a quick little spark note of, how can we take these files and put them not just as NFTs through Blender, which I know you guys have capabilities before, but I know you figured out a novel way on even how to embed these into Ordinals. And if people don't know, can't go into Ordinals 101 right now, but Ordinals can only be a certain file size, really only 60 kilobytes or up to 4 megabytes. So Michael figured out a way how to embed these large images, or at least the source code of them, and to create these generative artworks using the Bitcoin blockchain. So maybe you can just give like a little short description of that and something that we can go into in future workshops.
All right, I think I'm unmuted. I'm not sure what's up with my camera. Okay. Yeah, so basically what's cool about these files is that you can make a really complex geometry nodes scene inside of Blender that you can that I've written code which compresses it down to about 100 kilobytes for the actual generator itself, and then embeds that into a JavaScript file, which is stored on the Bitcoin blockchain as an ordinal. So what that means is that for each ordinal that you would make as a creator, you can include a reference to the provenance JSON file, which is stored on Bitcoin, which will show Blender or any website that uses Blender libraries how to regenerate your art. And this is very similar to the way on-chain art is stored in ETH in Ethereum smart contracts, but with the Bitcoin blockchain and with Ordinals, being able to store these like 100, 200 kilobyte files and have the complete art generator is something that you don't really have the ability to do on Ethereum, because it would be incredibly expensive. Instead of like the $50 to $100 storage fees that we might pay per one collection on Bitcoin, you would be paying like thousands of dollars for that on Ethereum. So the ability to store just 100 kilobytes is really something that opens up a lot of new opportunities when it comes to generative art on chain. And the reason people really love this generative art that's where the generator is stored on chain is because as an artist, you can say, well, we don't know if the art's going to be around in 1,000 years, but it'll be around for as long as Bitcoin is around. If someone has a backup of all the blocks on the Bitcoin blockchain, they will have a backup of this art, and it'll be regeneratable, to anybody that has the interpreter for it. And in this case, the interpreter is Blender. With JavaScript based art, the interpreter is a web browser. So it really goes hand in hand with that. Anyway, let me see if I can unmute Scott so you can close it out.
No, that's awesome. Yeah, Michael, thank you so much. And no, really, everyone, thanks everyone that's still here. It's a great turnout throughout the whole time. Thanks for watching this live. We're gonna cut this up and get this out over the weekend. So you know, when you see it on Twitter, please amplify it. We're gonna be doing another one of these workshops soon with Michael, you know, kind of taking it to even the next steps. And no, thanks everybody for joining us on this awesome Blender journey. I know I learned a lot. I'm going to get started with this 20-minute Blender tutorial so I can keep up and start working on the files as Michael's doing it for next time. So thanks so much, everyone, and see you soon.
Thank you, everyone. Bye.